Hey, welcome to Flip Classroom for AP Calculus. Today we're going to discuss Section 1-2, Part 1. Section 1-2 involves finding limits and one-sided limits and also something called the sandwich theorem. Today we're going to talk about a couple ways to find limits. First, we need to know some properties or rules for working with limits. The first one would be what we call the sum rule. And it says if the limit of f of x equals L as x approaches some constant c, and the limit of g of x equals m as x approaches the same constant c, then the limit of f of x plus g of x as x approaches c is simply L plus m. You just add them together. Product rule says that the limit of f of x times g of x is equal to the product of those individual limits, L times m. And the quotient rule says the limit of f of x divided by g of x, that would be a rational function, equals L divided by m as long as m does not equal 0. Here would be some examples. Let's consider y equals x squared and the function y equals x cubed. Suppose we want to find the limit as x approaches 2 of the sum of these two functions. Well, the individual limits of these two functions would be 2 squared plus 2 cubed, which is 12. Similarly, if we wanted to find the product of these two functions, x cubed times x to the second, which would be x to the fifth, it would just simply have a limit of the product of the individual limits, 4 times 8, which would be 32. Not too bad. Some more properties. The constant multiple rule. The limit of k times f of x is simply k times the limit of f of x. K would be some constant. So in that case, let's say the limit of 5 times x cubed would be, as x approaches 2, would be, well, when 2 goes into x cubed, that would be 8, and 5 times 8 would be 40. The root rule. The limit of f of x raised to some root is just the root of the limit, or the limit of f of x raised to 1 over n, where n is an integer, would just be that limit raised to the same power. Limits of polynomials. A polynomial, if you remember, is just, ax to the cube plus bx squared plus c. They're very easy to find. Okay, all you do is just substitute the value you're trying to approach into the polynomial. So if we have one like y equals 5x to the fourth plus 2x squared, the limit as x approaches 2 can be found by direct substitution, which would be 5 times 81. That's actually, that's a mistake. It would be 5 times 16 plus 2 times 4, and so that would be 80 plus 8, which would be 88. Limits of rational functions can also be found by substitution as long as the denominator is not equal to 0. For example, if y equals x minus 1 divided by x minus 3, the limit as x approaches 2 would be 2 minus 1 over 2 minus 3, or negative 1. Remember, though, the denominator cannot be equal to 0, because that's a no-no. But what do you do if the denominator is 0? Well, not to worry. In some cases, we can fix that. If y equals x squared minus x minus 2, and let's say the denominator is x squared minus x, we want to find the limit as x approaches 1. Clearly, that would be dividing by 0. We can use a technique known as the cancellation technique. First thing you do is factor the top. So I factor the top to x minus 2 times x minus 1. And the bottom I factor to x times x minus 1. Now you can see that there's a common factor in the top and the bottom, x minus 1. We can cancel that as long as that factor does not equal 0. And it doesn't equal 0 because we do approach 1, but we don't quite get to 1. So it will be some number, but very, 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 very small number. So I would cancel that factor, which lets us which leaves us with just on the top x minus 2. And then we would substitute the value of x, in this case 1, into what's left. Multiplying by the conjugate. Let's suppose that f of x equals the square root of 2 plus x minus the square root of 2, that whole thing over x. And we want to find the limit as x approaches 0. Alright, well clearly this is a rational function and we can't divide by 0. But we can do a trick. If you remember, the conjugate is just the same term but you change the sign. So for example, in this case, the numerator is the square root of the quantity 2 plus x minus the square root of 2. The conjugate of that would be the square root of 2 plus x plus the square root of 2. So we're going to multiply by the conjugate over itself, which in fact, that fraction would be equal to 1. So you can see I have the conjugate listed here. When we multiply this problem by the fraction equal to 1, the numerator is the difference of two squares, which essentially comes out to be 2 plus x minus 2. That's fortunate because that reduces to x. And the denominator we're just going to leave as the product of x times the square root of 2 plus x plus square root of 2. Now, I can cancel the x because it's a common term in the numerator and the denominator. So that would leave 1 on the top and our conjugate on the bottom. Now, if you notice, if I stick 0 into that conjugate, what I get is the square root of 2 plus 0 plus the square root of 2, which is simply 2 square root of 2. So the final answer would be 1 over 2 square root of 2. And that would be the limit of this function as x approaches 0. For practice on that, I would like you to work on problems 1 through 14. Some of these problems have multi-parts, so there's actually more than 14 problems. Sorry about that. On pages 108 to 109. Next time we'll talk about part 2 of this section. See you later. Bye.